Welcome back to part 2 of the exponential functions notes. We left off with this problem. In 2000, the world population was about 6.09 billion people. During the next 13 years, the world population increased, so that's going to tell me its growth, by about 1.18% each year. Write an exponential growth model giving the population y in billions t after year 2000. Estimate the world population in 2005. So in the year 2000, so this is going to be the 6.09 will be our initial amount. So f of t, because we're talking about a function in terms of time, or if you don't want to use f of t, you could say y equals. But our initial amount is 6.09. That's what we're starting with in 2000. And it is increasing, so we're going to want to do 1 plus 0.0118 to the t power, and t for years. So we could have 6.09 times 1.0118 to the t power. Now I want you to notice that I changed that percent into a decimal. So I had to move the decimal over 2 spots, and that's how I got the 0.0 there. Okay, so here's our function, and now it says estimate the world population in 2005. So in 2005, we're talking about 5 years after 2000. So we're going to want to put a 5 in for t. So y equals 6.09 times 1.0118 to the 5th power. So you will need your calculators for this. I would not use your calculator on your phone because you may have a difficulty finding the exponent for it. And so when I plug this into my calculator, I get a world population in 2005 of 6.45, and if we round it, 8 billion people. And of course, our numbers are much higher now because this is now the year 2017 instead of 2005. Okay. So example number 5, what if? In example 2, the value of the car can be approximated by this model. Identify the annual percent decrease in the value of the car. So previously it was y equals 25 times 0.85 to the t power. Now we have 0.9. When it was 0.85, it was 0.15, or a 15% decrease. So because it's now 0.9, that means it's 0.90 as a decimal. So if we were to do 1 minus this, we're going to get a 10% decrease. And then number 6, in example 3, assume the world population increased by 1.5% each year. Write an equation to model this situation. So in example 3, the one we just looked at, it was y equals 6.09 times 1 plus. Now we have to write this as a percent, or as a decimal, not a percentage, to the t power. So 1.5% as a decimal is going to be 0.015 to the t power. So our equation is 6.09 times 1.015 to the t power. And they're just using t for time instead of x. So another real life example is talking about compound interest. When you go to purchase a car or a home, the bank will charge you compound interest. And this is the formula for compound interest, where A is going to be your amount, P is going to be the principal, and not like Miss Addis, the principal meaning how much is deposited or how much you are borrowing from the bank. And then here's your 1 plus because it's growing, and R stands for rate, N stands for the number, not hashtag, of times. It's compounded. And N, again, it's the same N. And T stands for time. And most of the time, we're usually talking about years. So you deposit $9,000 in an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. So we need to know a couple of things. P in this case is going to be $9,000. That's how much we're depositing into the bank. Our rate is 1.46%. Let's change that into a decimal. 0.0146. T for time is going to be 3 because it's 3 years. And then this compounded quarterly, if you think about how many quarters are in a dollar or quarters in football, in either case, quarterly is going to mean 4 times a year. So our formula is A equals P times 1 plus R over N to the NT power. So we're going to have 9,000 times 1 plus, and it's going to be 0.0146 divided by 4 to the 4 times 3 power. So I'm going to use my calculator and I'm going to simplify this first. In my calculator, I'm going to type 1 plus 0.0146 divided by 4. And because my calculator has order of operations, it will tell me the nice answer of 1.00365. And now I'm going to do 4 times 3. 4 times 3 is the 12. Is 12. So we're taking it to the 12th power. So 9,000 times 1.00365 to the 12th power will be $9,402. And because we're talking money, this is going to be 21 cents. So our final amount is $9,402.21. Please make sure your dollar sign is in front. Never put your dollar sign behind the numbers when we're talking about money. So after 3 years, you will have earned an extra $402.21 just by keeping your money in that particular bank. So what if, in example 5, we find the balance after 3 years when the interest is compounded daily? So daily usually happens when you have a credit card and interest is charged to you daily. So this is going to be 9,000 times 1 plus 0.0146 divided by something times something, or to the something times 3 power. So daily, how many days are in a year? That's 365. So we're going to divide this by 365. So if I take what's inside the parentheses here, 1 plus 0.0146 divided by 365. This will give me 1.00004. And 365 times 3 will give me 1,095. So that's how many times this will actually be compounded over the 3 years. So 9,000 times 1.00004 to the 1,095th power. And that will give you $9,402.95. So by compounding it more often, you've actually made a little bit more money. So $9,402.95. And this is why credit cards will charge you daily interest, because they can charge you more money that way. All right, in our last slide, we have a response log for you to write in your notes here, and I will check them. It says, select from, at first I thought, but now I think. Or what confused me the most was, or I was successful in. So choose one of these sentence starters. At first I thought, blah, 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 but now I think. Or what confused me the most was, or I thought I was successful in. So at the end, this is kind of our summary for this lesson. This is how I can tell if you understood this well enough or not well enough. So at first I thought exponential functions looked like lines, but now I think, tell me what they look like. Or what confused me the most was how to enter the numbers into the calculator. Or I was successful in understanding and then fill in the blank. All right, and I will be checking these when you turn in your notes to look for your reflection on this piece.